The top right slide here is all our information we need to know about quadratic formulas, or what the quadratic formula is. So just a reminder that quadratics in standard form are in that ax squared plus bx plus c. As soon as we set this equal to 0, okay, so when we set our quadratic equal to 0, our task is now to solve and find the x values that make the equation equal to 0. Sometimes we'll be able to do that using square roots, not always though. Other times we might be able to factor. And when in doubt, when neither of those things can work, and that's going to happen fairly frequently, the method that will always give us our solutions is this quadratic formula, which is this right here. So the quadratic formula reads x equals negative b plus or minus the square root of b squared minus 4ac, and all of that is being divided by 2a. You need to memorize this. So as a way to help memorize this formula, every time I use it, I write it down, including the letters, and then we'll plug everything into it. So a couple things. When do we use the quadratic formula? So there's a couple kind of reasons for when we're going to use it. First thing we're going to make a note of is when a quadratic is equal to 0. So when a quadratic is equal to 0, and we should only think to use this quadratic formula when we can't factor or can't solve by using square roots. So when we can't factor or solve with square roots. And as we go through these today, I'm going to kind of go through this process of, hey, might I be able to factor? And if we can't, why can't we factor it? And I'll also kind of think about, might we be able to use square roots? Because now, this is the third method of how we're going to be able to solve quadratics. And if I just gave you a quadratic, what is like the thought process that we're going to go through to eventually arrive at the quadratic formula? Okay, we'll typically want to factor use square roots first. What do the solutions answers from the quadratic formula represent? Again, there's a couple parts here. They're the x values that make y equal 0. Now, there's a name for that graphically. So if we took all the points or all the x values for when y is 0, all those points lie on the x-axis, which means that these points are the x-intercepts. And an x-intercept is where the graph crosses the x-axis. Okay, those are actually, this extends to the quad or factoring. When you solve and we factor and we get those x values, those are also x-intercepts. When we solve with square roots and we get values, those are also x-intercepts. Okay, so anytime that y is 0 and we solve for x, those values are where the graph is going to cross the x-axis at. All right, one thing that will always hold true no matter what method we need to use to solve is when we see a quadratic equation, we need to get one side equal to 0. Okay, so that's going to be our first step here. Step 2 is we need to identify what the a, b, and c value are. When we do that, know that a, b, and c are just numbers, meaning we will not include the x squares or the x's. They are just the coefficients in front of all those terms. Then we'll simplify inside the radical being the square root part. Simplify the denominators, the 2 times a, and then we'll split the equation into 2 and come up with our 2 answers. So there's a lot of steps here. Okay, and the first couple, or at least the first one, we have it all kind of lined out for us. And again, we're going to write this formula over and over again since we're going to work on committing that to memory. So we're going to solve the equation of 5x squared plus 10x minus 17. Again, the first thing I would check for is, can I use square roots? Well, no, we can't use square roots because of the b term being present. We're only able to use square roots if I can get the x squared by itself equal to a number. So no square roots. I'm like, hey, can I factor? Okay, we're going to check that. Okay, we might be able to here. If we can factor, that means that there are two numbers that add to 10 or add to b and multiply to a times c, which is negative 35. Let's try that again, Mr. Youngren. 5 times 17 is negative 85. Right? 17 times 5. Yeah, 85. All right, so I'd be looking for these numbers. Can anybody think of the numbers that meet these conditions, multiply to negative 85 and add to 10? I don't think they exist. And it's at this point that we realize this is not factorable, and thus we need the quad formula. Okay, so that's one thing I want us to keep in mind. When do we absolutely have to use the quad formula? And it's after we realize that we cannot factor. And quadratics won't factor if we can't find the numbers that add to b and multiply to a times c. Okay, so I want to continue to push that thought process just so that we have like a really good skill set of how to solve quadratics. So we ruled out that we can't use square roots. We just ruled out that we can't factor. So we're like, hey, what will always work is this quadratic formula. This will always give us the solutions. Even when it's factorable, quadratic formula still works. Even when we're solving with square roots, this still works. So this formula actually works 100% of the time in certain cases. All right. So now that we've landed on that we're going to use the quadratic formula, let's put this all to use. So I want to identify a, b, and c to start. The value of a is the number in front of x squared. That is going to be 5 in this case. And it is just the 5. I'm not changing it. I'm not squaring it. I'm not including the x squared. It is literally the number in front of that x squared. B is the number in front of the x. So that is going to be 10. I'm not including the x. I'm not changing the sign. Literally the number in front of the x there. Then c, that's our constant term. That is negative 17. And so now we're going to take all these numbers or all the values of a, b, and c and plug it in to the quadratic formula. And use of parentheses here is so important. So our quad formula is now, or plugging all the values in, x equals negative b means to take the b value that we identified and make it negative. So that's negative 10 plus same b value is going to show up again. So that's 10 squared, and then minus 4 times 5 times negative 17. And know that we're square rooting all of this. Then our denominator is 2 times a, which is 2 times 5. Again, use of parentheses there makes a really big difference. In fact, I probably should have used parentheses here around that 10, but they actually don't make much of a difference. All right, now our task is to simplify inside the radical and then simplify the denominator. This is 10 squared and then minus 4 times 5 times negative 17. We can actually just let the calculator do all the work for us here. Okay, and I'm going to type that in exactly as I see it. Now, this is where parentheses really matters when we go straight to the calculator, and especially when we start squaring values. So we're all going to start, and everyone's calculator is a little bit different, so you might need to look for some of these buttons here. I'll make sure I go slow so we can find everything. If you get stuck finding a button, ask somebody next to you if they can't find it. And after we've gone through an example, if you still can't find some of these buttons, I'll be happy to come show you. So we're going to type everything underneath the square root in at one go. So we're going to go open parenthesis, then 10. I'm going to close that parenthesis. This needs to be squared, so I'm going to square it. Now this next part is really important because most calculators have either a negative button or a subtraction button. We want to use this subtraction button because we are subtracting that 4 times A times C. So that's 4, and then the other numbers will go in parentheses, so times 5, and then times, this is where I now use the negative button because 17 is negative, not the subtraction button. 17, close parentheses and press enter. I get 440. So the quadratic formula, we now have negative 10 plus or minus the square root of 440, and it's all being divided by 10. All right, we're not quite done yet. The next thing that we're going to do is we're going to square root 440, and most of the time when we do this, we're going to get a decimal value. Just to kind of keep things consistent in here, why don't we plan to round to 2 decimal places? Okay, and we'll just always plan to do that when using the quad formula. So your square root button is going to show up as the second option of taking x squared. So you should be able to find an x squared button on your calculator. We want to press second and then the x squared to bring up that square root. So square root of 440, and we should get a value of 20.97. We're rounding, actually we should round up here. That should be 20.98 because of that 6. So this is negative 10 plus or minus 20.98, and it's still being divided by 10. Okay. Next thing we're going to do is split the equation into 2. The reason we need to do that is all based on what happens with square roots. And this is something I had you all do on Friday. When we take square roots, it'll always be plus or minus that value. And so the splitting up into 2 equations is us dealing with that positive root and dealing with that negative root. So this is x equals negative 10 plus 20.98 divided by 10, and x equals negative 10 minus 20.98 divided by 10. And so now we just need to work to simplify both of these to get to our final numerical answer. First, we need to simplify the numerator, meaning we need to do the addition or subtraction, and then we can divide. So negative 10 plus 20.98. Let's try that again. Is 10.98. And that's going to get divided by 1. And I have negative 10 minus 20.98 is negative 30.98 and divided by 10. Last thing, we'll divide by 10. So 10.98 divided by 10 gives me 1.098. And then negative 30.98 divided by 10 gives me negative 3.098. All right, and we get our 2 solutions there. And with every quadratic, we're basically shooting for 2 solutions. All right, there's a lot going on with the quad formula, right? There are a lot of steps. There's a lot of things to take note of, a lot of really small things. So attention to detail matters, and practice definitely helps. We're going to do example 2 together, and then actually the rest of these we'll probably kind of work at our own pace, and maybe I'll put up the answer key to these notes up on the board, and we can kind of check our work and then grab homework after we're done with these. But let's do one more together, and we're going to start over all from the beginning again. All right. So right now, again, we're going to pretend that this just showed up on like an assessment, let's say, and it says, solve the equation. It doesn't say which way to solve it. Well, the fact that we have an x squared means that we need to get one side equal to 0. So I'm going to subtract 2x and I'm going to add 6. So subtract 2x and add 6. That makes the right side 0. All of this cancels. The left side becomes 9x squared plus 5x and then minus 9. So I've got one side equal to 0. And again, my task is to be able to solve this quadratic or find the x values that make y equal to 0. First thing I try is, can I solve with square roots? Well, I can't do that because of this x being here. Whenever we have x squared and x's, square roots will never be an option. So I'm like, okay, maybe factoring. If it's factorable, that means we should be able to find two numbers that add to b, which is 5, and multiply to a times c, which is negative 81. Anybody think of those numbers? I don't think they exist again. Right? Add to 5, multiply to negative 81. Yeah, I don't think those exist. Okay, so since we can't find these numbers, since those numbers really don't exist, or at least not whole numbers for that, this is where we now resort to the quadratic formula. And again, the quad formula works. Even if it was factorable, we still could use this quad formula. All right, so here we go with the quad formula. In this case, A is 9, B is 5, and C is negative 9. So plugging everything into the quad formula, we have x equals, starting with negative b, so that's negative 5, plus or minus the square root of b squared, so that's 5 squared, minus 4 times a, which is 9, times c, which is negative 9, and then all over 2a, which is 2 times 9. Again, notice my use of parentheses there. Really important, especially since we're relying on the calculator to do a lot of the work for us. All right, we're going to figure out what value we get underneath our square root by plugging that into our calculator exactly as we see it. Again, the parentheses are really important here. So I'm going to go open parenthesis 5, and that's going to be squared. Then minus 4, open parenthesis 9, open parenthesis. Now make sure you use that negative button here. So we've got subtraction button first, subtraction in front of the 4, negative button in front of the 9. And you should get that we are square rooting 349. So this quad formula is now negative 5 plus or minus the square root of 349, and it's being all over 18. All right, let's take the square root of 349, see what decimal value we get. Again, that square root is going to happen as the second option of the x squared. So second, 349, and you should get 18.68, rounded to 2 decimal places. So that means we have x equals negative 5 plus or minus 18.68 all over 18. Yeah, Dean, what you got? So I got 349 by doing the 5 squared minus 4 times 9 times negative 9. All of that I just did in the calculator here. So 5 squared and then minus 4 times 9 times negative 9 is 349. Yeah, 5 squared is 25, and then 9 times negative 9 is negative 81. But then that 4 really works as a negative 4. So think about that as a negative 4 times negative 9 to make that positive, okay? All right, now we're going to split this up so that we have the plus or minus, so negative 5 plus 18.68 divided by 18, and x equals negative 5 minus 18.68 and divided by 18. We have to deal with the numerator first, so doing the addition and or subtraction. So negative 5 plus 18.68. That's 13.68. Still needing to be divided by 18. And then negative 5 minus 18.68 is negative 23.68, also still needing to be divided by 18. And let's see what happens when we do that division. 13.68 divided by 18 is 0.76. So x equals 0.76. And then negative 23.68 divided by 18 equals negative 1.32. Okay, and again, we'll just always round to 2 decimal places with this, just so we can keep that consistent. All right. Any questions here before we start getting some practice on our own? All right, go ahead and flip the page over. And let's start here. Why don't we all do example 3 on our own or in our groups? Remember, you need to get one side to be 0 first. Identify A, B, and C, and just see what you come up with the quad formula. Okay, we'll probably end up skipping number 5. We'll just do 3 and then 4. Okay, so if you need more space, you can just work down into that space that example 5 is providing. All right, I'll give you all a few minutes. Don't want to rush this. Make sure you're actually trying, not sitting there just waiting for me. Okay, give it kind of the initial steps here before we get to the weird thing that really we haven't seen yet. So you got to start by getting the right side to be 0. I add 5x, I add 1. That means the quadratic that I'm trying to solve is 4x squared minus 2x plus 6. That means A is 4, B is negative 2, and C is 6. Now, a really good question, that I get asked fairly often is, what does negative B mean? Negative B means we're taking whatever the B value is and multiplying it by negative 1. The parentheses can help with that. So I just put B in parentheses and I still have that negative. So in this case, negative B is actually a positive 2. Okay, negative B does not mean just make it negative and leave it that way. Okay, it means to switch the sign or multiply it by negative 1. Then we're doing plus or minus the square root of negative 2 squared minus 4 times 6 and all over 2 times 4. Now again, when you type this into the calculator, you need to be careful because you can get some wrong values. First chance where you could get a wrong value is if you don't put parentheses around the negative 2 squared like that, it's going to say that it's negative 4. That's not the case. What the calculator is doing is it squares the 2 first and then multiplies it by negative 1. It's going through order of operations. So you first need parentheses around that negative 2 when we square it. Then, press, let's not open that, it's going to be too loud. Then, instead of the subtraction button, we need to go minus the 4. Otherwise, it multiplies that whole value by negative 4. We needed to subtract from this. Okay, so we're minusing 4 times 6. And you should get negative 92. Now, this is where the weird thing happens. When I then go to take the square root of negative 92, I get an error. And it says non-real answer. And eventually you're going to learn that there's something called an imaginary number that allows us to actually get a solution here. So for us, when we see this, that means that there are no real x values that make y equal to 0, and thus there are no x-intercepts. So we're going to actually just say what the calculator tells us. We're going to say non-real answer. Now, if you do say no solution, I'll still accept that. But really, the mathematical way of describing the situation is that it is a non-real number. It's what's called an imaginary answer. All right. Well, let's do one more. Hopefully, we don't get this to work out to be a non-real answer. I want us to actually get a numerical value here. So let's do example 4 as the last one. And we'll just do it like how I just had y'all work through it. Okay, work on it in your groups. Make sure you get one side to be 0. And you know what? Let's do this. Let's get the right side to be 0 just so that we're all doing the same thing. So subtract all these terms to the left side here. All right, we'll give us like 5 minutes to do your very best here. Again, I just need you to try. Does not need to be perfect.